Here is an explanation for the answer to final exam question number 90 in Physics Demystified, 2nd edition. If you have the printed book, please see page 535. Now this question starts out by saying auroral communication can occur. That is a mistake. That is a mistake. It should say meteor-scatter, communication or propagation. Propagation of radio waves by a mode called meteor-scatter. So it should say meteor-scatter communication can occur in the very high frequency part of the radio spectrum over distances up to about 2,000 kilometers or 1,200 miles. The maximum possible communications range depends on all of the following factors except one. Which one? And then we're given 5 choices. Well, meteor scatter typically occurs when meteors from outer space enter the Earth's atmosphere and burn up, thereby producing what are sometimes called shooting stars or falling stars. A lot of times during certain parts of the year we'll get what we call meteor showers, where a whole bunch of little meteoroids from outer space encounter the Earth from more or less the same direction, and you get, for example, the Perseids coming out of the constellation Perseus, and the Orionids coming out of Orion, and things like that. Well, when they encounter the upper atmosphere of the Earth, the ionized regions called the ionosphere, and then they proceed downward through the stratosphere, they create little trails of ionized atoms. Little trails of ionized atoms which can reflect radio waves from the surface. And when that happens, you may have a station, say here, and a station, say here, maybe 1,000 kilometers away. They're not on a line of sight, but maybe a radio wave will bounce off one of these trails and you'll get a little burst of signal. Here's the transmitter, here's the receiver. The receivers will hear a little burst of signal from this transmitting station even though it's over the horizon. That is meteor scatter, propagation. If there are enough meteors, like a meteor shower, especially a heavy meteor shower, you can carry on continuous communication by means of this mode because there are just so many ionized trails. But there is one thing that among these choices that does not affect the communications range, and that is the waveform of the signal. So if it's amplitude modulated or frequency modulated or Morse code, the waveform doesn't have any particular effect on the range, although it stands to reason because of all of these changing conditions that certain modes of communication will work better than others. Frequency modulation is a very poor choice. Phase modulation, very poor choice, because these effects tend to introduce frequency and phase modulation under the signals. But Morse code, that works pretty good for that purpose. So the answer here is A. The waveform doesn't actually affect the range. The orientations of the trails will affect the range. The altitudes, how high up they are, certainly will. And the locations of the transmitting and receiving stations obviously will affect the range that we get, because that's by definition how far apart they are. But the maximum possible communications range that we can get will depend on all of the factors B, C, D, and E, but not on factor A. So A is the answer we want.